Hi everybody. So let's continue our discussion upon the same head, which was multinomial expansion. Multinomial expansion. That means expansion of more than two terms basically. So when two terms were involved, we said it was a binomial expansion. When more than two terms get involved, we say it's a multinomial expansion. And the fashion in which we are able to expand more than two terms corresponding to any natural number n is something that we already saw in the last lecture. So if I have x1, x2 and so on xk be any real numbers let these be any real numbers, then we saw that if we wish to talk about the multinomial expansion of x1, x2, x3 and so on xk corresponding to the natural number n, that means x1 plus x2 plus x3 and so on plus xk whole to the power n, we can write it in the compact form of summation, which is summation n factorial whole upon as many as there are variables, those many terms are going to come, because corresponding to each I will have 1. R1 factorial into R2 factorial into R3 factorial and so on Rk factorial, multiplied by x1 to the power R1 into x2 to the power R2 and so on xk to the power Rk. And how are these terms coming into picture? Each and every solution of this equation R1 plus R2 plus Rk equals n is actually turning out to be a term over here. So if there is one R1, one R2, one R3 and so on, one Rk such that their sum is n, that one R1 is going to sit over here, R2 will sit over here, Rk will sit over here and will sit over here and will create a term. N is fixed. Clear? So corresponding to each solution of this equation I am going to have my terms. Similarly, from here I can extract a general term. If this is the sum of all the terms, then a general term will be from here to here corresponding to this situation being true, right? That also we saw regarding the general term of this very equation. The general term of this multinomial expansion is also something that we have saw. So if I talk about this question regarding the coefficient of multinomial expansions. So in the last lecture also we saw one of those queries, but then over there a direct substitution of RST actually gave us the solution. Over here suppose I have xy plus 3yz plus 5zx whole to the power 6. In this multinomial expansion, find the coefficient of x to the power 3, y to the power 5 and z to the power 4. You have to first of all find a term in this multinomial expansion which contains this particular expression. Apart from this expression, whatever comes in the adjoining of this particular expression will be its respective coefficient in this multinomial expansion. So in this multinomial expansion I have to find the coefficient of this. See, in the process of obtaining the coefficient only, we get a guarantee whether this term is actually occurring in this expansion or not occurring, because if this is not occurring in this expansion, suppose that this is not occurring in this expansion, in that case the coefficient will be 0. If it doesn't occur in this expansion, coefficient will be 0. Right now the statement is not signifying anything about this occurring in the expansion or not occurring in the expansion. So in the process of finding the coefficient only, it will be clear to us. So let's begin with that. How to actually proceed with finding the coefficient? See, you have this xy plus 3yz plus 5zx to the power 6 will be equal to what? This will be equal to summation 6 factorial whole upon r factorial into s factorial into t factorial multiplied by xy whole to the power r 3yz whole to the power s and 5zx whole to the power t, where r plus s plus t is 6. This is what will be equal to the multinomial expansion of xy plus 3yz plus 5zx to the power 6. If this is what my expansion looks like, I am searching that term which has this expression. So let's talk about a term in general. The general term of 1, let me name this 1. The general term of this multinomial expansion is what? It will be from here to here with this condition being true. So it will be 6 factorial upon r factorial into s factorial into t factorial into xy to the power r into 3yz to the power s into 5zx to the power t, such that r plus s plus t is 6. Clear? That is, this is one general term corresponding to a solution of this equation. Clear? So this will be 6 factorial upon r factorial s factorial t factorial. This will be x to the power r, y to the power r, 3 to the power s, y to the power s, z to the power s, 5 to the power t, z to the power t, x to the power t, such that r plus s plus t is 6. Now you can club the terms. X to the power r, x to the power t gives you this. Y to the power r, y to the power s gives you this. Z to the power s, z to the power t. This is how the variables are behaving, and if I talk about the numbers, you have 6 factorial upon r factorial, s factorial, t factorial into 3 to the power s into 5 to the power t. So this is the numeric value of this term, and these are how the variables are behaving. Clear? Such that r plus s plus t is 6. Now this is how a general term looks like in this multinomial expansion. I want a term which has this expression. If x, y, z are sitting in every term of this multinomial expansion, which they are, then I want x to sit with this power, y with this power and z with this power. Catch hold of that term of this multinomial expansion which has x, y, z sitting in this combination. So over here, in this general term, x, y and z are sitting in this combination, such that this is true. If I want x, y and z to sit in such a combination that over here I should get a 3, over here I should get a 5, over here I should get a 4, in that case what basically I want is r plus t to be equal to 3, r plus s to be equal to 5 and s plus t to be equal to 4. To get a term containing x to the power 3, y to the power 5, z to the power 4, we have This is only possible when r plus t happens to be equal to 3, r plus s is equal to 5, s plus t is equal to 4, all these things such that r plus s plus t is 6. Because if r plus t turns out to be equal to 3, this will be 3, this will be 5, this will be 4, and I am going to get. So, for which r, s and t is this equals 3, this equals 5, this equals 4, such that if I get those r, s and t, I am going to incorporate them over here and get the coefficient of this term. But mind it, what is it that we want? We want such an r, such an s, such a t, such that this and this and this is satisfied without violating this. Because if I get r, s and t which is satisfying this, that means there is some combination of r, s and t which I get such that r plus t is 3, r plus s is 5, s plus t is 4, but it is not satisfying that its sum is equal to 6. In that case, this term itself, x cube y5 z4, this term itself can never occur in this multinomial expansion, because whichever terms occur in this multinomial expansion, the sum of the indices of x, y and z, they have to add up to give you 6. So, if 4, 3 or whatever RST, whatever RST you get, if that is not adding up to give you 6, you are going to say that this x cube y5 z4 term is not occurring in this multinomial expansion, and hence the coefficient is 0. So, basically what I am trying to say is I want such an r, such an s, such a t which satisfies this, this and this, all 4 equations. Even if one is not satisfied, the coefficient of this is 0. There is no valid, good, right r, s and t such that they satisfy all 4. That means this term that we want, x cube y5 z4, is not occurring in this expansion, and so the coefficient is 0. This is always true. This is always true. If you are not getting valid r, s and t's, declare that this term doesn't exist, and therefore the coefficient becomes 0. So, over here let us continue our discussion. So, I want such an r, such an s and such a t such that r plus t is 3, then I want r plus s is 5, and then I want s plus t is 4, and I want r plus s plus t is 6. Now see, if r plus t is 3, r plus t is 3, or let me one by one compute that. You have r plus s plus t is 6, and if I say r plus t is 3, this implies this equation becomes what? This becomes s plus 3 equals 6, because r plus t is 3, which implies s is equals to 3. Are you understanding? S is equal to 3. Once we have done this, that means s has come out to be equal to 3 with the help of first and this equation. If I go on to the other, you have r plus s equals 5 and r plus s plus t is 6. So, if r plus s is equal to 5, this becomes 5 plus t is 6, t is 1. And in the end I have s plus t is 4 and r plus s plus t is 6, s plus t is 4, so I can write this as r plus 4 equals 6, so r is 2. So, such an r, such an s and such a t I have got which satisfies all the 4 equations. You can see r plus t should be 3, r is 2, t is 1, 2 plus 1 is giving you 3, r plus s should be 5, r is 2, s is 3, 2 plus 3 is 5, s plus t is 4, s is 3, t is 1, 3 plus 1 is 4. The first question says that in the expansion of x plus a whole to the power n, the sum of even terms is e and that of odd terms is o, then OE is equal to what? So, you know that x plus a whole to the power n is actually equal to the sum of even terms plus the sum of odd terms. So, it is equal to O plus E. I am being asked to compute OE. So, if you observe, what is O plus E whole square minus O minus E whole square? What is this? This is equal to nothing but 4 times OE, right? And you know that this is sum of even terms plus sum of odd terms. If I talk about x minus a whole to the power n, what would this be equal to? This will be equal to O minus E, isn't it? If this is O plus E, this will be O minus E, right? That's how the expansion is different of x minus a to the power n from x plus a to the power n. So, over here, if this is the very valid thing, then OE is equal to O plus E whole square. So, O plus E is this. So, x plus a to the power n squared, that means 2n, minus O minus E whole square, that is x minus a whole to the power n whole square upon 4. That is what is your OE. Is it understood? So, therefore, we basically say x plus a whole to the power 2n minus x minus a whole to the power 2n whole upon 4 is actually equal to the value of OE. Easy enough? Next question is the coefficient of x to the power 4 in the expansion of x by 2 minus 3 by x square whole to the power 10. Let's see. So, over here I am saying, suppose there is this rth term, or I should say r plus 1th term, which basically has x to the power 4 as its very coefficient. So, tr plus 1 is what? It is 10 cr, because this is 10, x by 2 whole to the power 10 minus r minus 3 by x square whole to the power r. This is the general r plus 1th term in the expansion this. So, you get 10 cr x to the power 10 minus r minus 2r. So, 10 minus 3r, 2 to the power 10 minus r, minus 1 to the power r and 3 to the power r. Clear? Everything has been brought in the numerator. So, this is what? 2 to the power r minus 10. Because this is 2 to the power minus of 10 minus r, which is r minus 10. Then this is minus 1 to the power r, 3 to the power r. This already we have taken upstairs, right? So, if this is what is the r plus 1th term, I am wanting the coefficient of x to the power 4. So, I basically want that 10 minus 3r should be equal to 4. That means 6 is equal to 3r or r is equal to 2. So, it is basically the third term which has x to the power 4 in it. So, the third term becomes what? Obviously, x to the power 4 is there, because for r equals 2, this is x to the power 4. Then it is 10c2, because r is 2, 10c2, 2 to the power 2 minus 10, which is 2 to the power minus 8, or 1 upon 2 to the power 8, minus 1 to the power 2 is 1 only, and this is 3 to the power 2 into x to the power 4. So, what is the coefficient of x to the power 4? Coefficient is this, and the value when you evaluate, it comes out to be 405 by 256. That is what is the coefficient of x to the power 4 in this binomial expansion. Clear? Now, we have the next question which says that what is the middle term in this expansion. Let's see. Question is about the middle term. Now, over here, if you remember the very algorithm of calculating the middle term, because 2n is an even number, 2n is an even index. So, therefore, 2n by 2 plus 1th term is the middle term. That means n plus 1th term is the middle term, right? What is the n plus 1th term? So index is 2n. 2n Cn, 1 to the power 2n minus n, that is 1 only into x to the power n. So this is what 2n factorial upon n factorial into 2n minus n, that is again n factorial into x to the power n. Now 2n factorial can be written as 1 into 2 into 3 into 4 and so on, 2n minus 3, 2n minus 2, 2n minus 1, 2n whole upon n factorial into x to the power n. Now I can alternatively write this as what? I can write this as 1 into 3 into 5 and so on, 2n minus 3, 2n minus 1, all the odd terms together, multiplied by all the even ones. So 2 into 4 into 6 and so on, 2n minus 2, 2n, right? 2n minus 2, 2n whole upon n factorial into n factorial, and this multiplied by x to the power n. Now you basically have 1 into 3 into 5 and so on, 2n minus 1. From here you can see 2 is coming out common n times. So you basically get 2 to the power n, and now you are left with 1 into 2 into 3 and so on up till n, which is nothing but n factorial whole upon n factorial into x to the power n. So your answer comes out to be 1 into 3 into 5 up till 2n minus 1 into 2 to the power n into x to the power n upon n factorial. That is what is the n plus 1th term or the middle term. Okay. So what is your answer? This is your answer, 1 into 3 into 5 up till 2n minus 1 into 2 to the power n whole upon n factorial times x to the power n. Moving on to the next question, we have the greatest term in the expansion of 1 plus 3x whole to the power 54 when x is given to be 1 by 3. What is the greatest term? Again, a very basic algorithm which is going to come into picture over here. You calculate TR plus 1 and you calculate TR and then you calculate the ratio. TR plus 1 is 54CR 3x to the power r whole upon 54CR, this is TR, 54CR minus 1, 3x to the power r minus 1. X is given as 1 by 3, so this eventually becomes 1 only because x is 1 by 3, 3 into 1 by 3 becomes 1, 1 to the power r, 1 to the power r minus 1 is that only. So here you get 54CR upon 54C r minus 1. This becomes 54 factorial upon r factorial into 54 minus r factorial, and here you have 54 factorial r minus 1 factorial 54 minus r plus 1 factorial. Fine. So obviously this gets cancelled out. What are you left with is this can be written as r minus 1 factorial 54 minus r plus 1 into 54 minus r factorial whole upon r into r minus 1 factorial into 54 minus r factorial. So very clearly this gets cancelled out, this gets cancelled out, you are left with 55 minus r upon r. Next what you do? You consider TR plus 1 upon TR greater than 1. So you consider 55 minus r upon r greater than 1. From here you get 55 minus r is greater than r, or 55 is greater than 2r, or r is less than 55 by 2, which is 27.5. Clearly this is not an integer. We separate the integral part of it, which is 27, and plus 1th term is what is the greatest term. So 27 is the integral part, and therefore 28th term will be my greatest term. I just followed the algorithm, nothing great, right? Next we have the coefficient of x cube y to the power 4 z to the power 5 in this expansion is what? Let's see. So based upon multinomial expansion, the concepts should be very, very clear. You should know that xy plus yz plus zx whole to the power 6 is equal to summation 6 factorial upon r factorial into s factorial into t factorial, xy to the power r, yz to the power s and zx to the power t, such that r plus s plus t is 6. So from here you get what? Summation 6 factorial upon r factorial s factorial t factorial, r plus s plus t is 6. This becomes x to the power r plus t, y to the power r plus s and z to the power s plus t. You want the coefficient of x cube, y to the power 4, z to the power 5. So you want r, s and t's value such that r plus t is 3, r plus s is 4 and s plus t is 5, such that r plus s plus t is 6. If r plus t is 3, s automatically comes out to be equal to 3. If r plus s is 4, t comes out to be 2. And if s plus t is 5, r comes out to be 1. So r should be this, t should be this, s should be this to give you basically x cube, y to the power 4 and z to the power 5. And therefore, for r equals 1, t equals 2 and s equals 3, if I get here x to the power 3, y to the power 4, z to the power 5, its coefficient is going to come from here. Coefficient will be what? 6 factorial upon 1 factorial, 2 factorial, 3 factorial, which is this, right? Eventually becomes what? 6 into 5 factorial upon 6 into 2, which gives you 120 by 2, that is 60, and so your answer is that the coefficient is 60. So basically you get 60, this is 60, 60 x cube y to the power 4 z to the power 5, so coefficient of this is 60. Next question says what? Let's see. If C0, C1, C2 up till Cn are denoting the binomial coefficients in this expansion, then what is this expansion of? Let's see. So here I can see this is AC0 plus A plus BC1 plus A plus 2BC2 plus A plus 3BC3. So in short I can write this as, you can see over here it's already there, you can write it as A plus RB NCR. Okay, A plus RB NCR, R going from 0 to n. Because Cn is nothing but NCn, C2 is nothing but NC2. That's how we denote the binomial coefficients. So this comes out to be A times NCR plus summation RB times NCR. Fine. A comes out common, you're left with summation R going from 0 to n NCR, which you know is 2 to the power n, plus here what I'm going to do is B comes outside, I have R varying from 0 to n, R into, I can write NCR as n by r, n minus 1 C, r minus 1, r cancels, n comes outside, you get n times b, summation n minus 1 C r minus 1. Now if summation NCR is 2 to the power n, summation n minus 1 CR minus 1 is 2 to the power n minus 1. Right? 2 to the power n minus 1 comes out common, you're left with 2a plus nb. Clear? And that is what is the very value of this summation. It is what? 2 to the power n minus 1, 2 to the power n minus 1, 2a plus nb. Clear? The next question says that if x is very small in magnitude compared with a such that this is equal to this, then the value of k is what? Now over here for large index we have done the expansion. How do you basically talk about this term? How do you expand it? How do you find k? Let's see, a upon a plus x. First question says that if in the expansion of a minus 2b whole to the power n, the sum of 5th and 6th term is 0, then find the value of a by b. When I talk about the expansion a minus 2b whole to the power n, basically in this expansion, what is the general term? General term is given by NCR a to the power n minus r minus 2b to the power r. If I am saying 5th and 6th term add up to give you 0, so T5 can be written as T4 plus 1. So this becomes what? NC4 a to the power n minus 4 minus 2b whole to the power 4. And what about the 6th term? It is T5 plus 1, which is NC5 a to the power n minus 5 minus 2b whole to the power 5. Now they are adding up to give you 0. You know that minus 1 to the power 5 is actually minus 1 and minus 1 to the power 4 is 1. So when you add both of them you get 0. You actually are getting what? NC4 a to the power n minus 4 2b to the power 4 is equal to NC5 a to the power n minus 5 2b to the power 5. Right, I have just sent this T6th term to the right hand side and hence I have got this, which means NC4 upon NC5 is equal to a to the power n minus 5 upon a to the power n minus 4 into 2b to the power 5 upon 2b to the power 4. Right, so a to the power n minus 5 upon a to the power n minus 4, 2b to the power 5 upon 2b to the power 4. This gives you what? A to the power n minus 5 minus n plus 4, which is a to the power minus 1, and this gives you what? Into 2b. Because 2b to the power 4 gets cancelled, you're left with 2b, which eventually gives you what? Let's see. This is 2 times b by a. So what is a by b? If this is 2 times b by a, actually a by 2b will be equal to NC5 upon NC4. So a by b is twice of NC5 by NC4. What is NC5 by NC4? It actually gives you n factorial upon 5 factorial, which can be written as 5 into 4 factorial into n minus 5 factorial. And then you get n factorial because it is upon NC4. So n factorial, this is 4 factorial, n minus 4 into n minus 5 factorial. So this gets cancelled out, this gets cancelled out, this gets cancelled out. So you are left with what? This becomes 2 into n minus 4 by 5, and that is what is your a by b. So a by b turns out to be 2 into n minus 4 by 5, which is option number B. Now the moment we move to the next question, let's see what it says. It says in the expansion of 1 by x plus x tan x whole to the power 5, the ratio of 4th term to the 2nd term is 2 by 27 times pi to the power 4, then the value of x can be what all among these 4 options. So here when I am talking about 4th term to the 2nd term, again r plus 1th term will be what? 5cr 1 by x to the power 5 minus r and x tan x to the power r. So you have ratio of 4th term to the 2nd term. What is 4th term? 4th term is 5c3 1 upon x to the power 5 minus 3 x tan x to the power 3. So this gives you 5c3, this is x cube and this is x square, so you're left with x tan x to the power 3. Right, this was x cube, this is x square, so just left with a single x over here and tan x whole cube. Similarly, this is the 4th term. What the 2nd term is? 1 plus 1. So this is 5c1 1 by x to the power 1 or 1 by x to the power 4 actually. So 1 by x to the power 5 minus 1, x tan x to the power 1. So from here you get 5c1 tan x whole upon x cube. What is 5c1? 5 factorial upon 1 factorial into 4 factorial. So this gives you 5 tan x whole upon x cube, and this gives you 5c3. 5c3 is nothing but 10. So this is 10x into tan cube x. Right? Why? Because this is 5 factorial upon 3 factorial into 2 factorial, which makes this 5 into 4 into 3 factorial, 20 upon 2, that is 10. So 5c3 is 10. Now it is saying ratio of 4th term to the 2nd term. So what is this trying to say? It is saying ratio of 4th term to the 2nd term. So 10x tan cube x whole upon 5 tan x, and here x cube is given by 2 by 27 pi to the power 4. Eventually what are you going to get? This gets cancelled. This is 2, so you get 2 x to the power 4 tan square x equals 2 by 27 pi to the power 4. 2 gets cancelled. You are left with x square tan x equals plus minus 1 by 3 root 3 pi square. And what is that x which is actually going to satisfy this? It is nothing but pi by 3 and minus pi by 3. So your answer is pi by 3 and minus pi by 3. Moving on to the next question, we have this expansion given to us. What is this equal to is the question. Now see, this is pretty simple to actually first of all decode how this can alternatively be written. I can write this as minus 1 to the power k minus 1 nck a minus k whole square, right? Because C1 is nothing but NC1, C2 is nothing but NC2, so I can write it as NCK a minus k whole square. This k is running from 1 to n. Now this can be resolved further to minus 1 to the power k minus 1 nck a square minus 2ak plus k square. The moment you get this, your entire summation boils down to summation k going from 1 to n minus 1 to the power k minus 1 nck into a square minus 2a, again k going from 1 to n minus 1 to the power k minus 1 nck into k, this k, plus summation k running from 1 to n minus 1 to the power k minus 1 nck into k square. Now one by one let's try to understand. If I talk about this summation, I can write this alternatively as what? So this can alternatively be written as 1 minus summation k going from 0 to n minus 1 to the power k minus 1 nck, and this is nothing but equal to 0. So from here you get 1 as the answer of your this summation. Now when I am talking about this particular summation, this can alternatively be written as what? This can alternatively be written as summation k running from not 1 to n but 0 to n minus of minus 1 to the power k into nck, right? And this is nothing but equal to 0. Here also this will be k and not k minus 1, this is k. Fine. After this, when I talk about this summation, this again can be written as summation minus 1 to the power k nck into k square with a minus sign outside because I am taking k from 0 to n. And this again is equal to 0. So you are basically getting a square into 1 minus 2a into 0 plus 0. So you basically get a square into 1, and therefore answer turns out to be a square. A square into 1 minus 0 actually gives you just a square as the answer. Now if you move on to the next question, what is it that we have now? Let's see. The value of n what is it when all these things are basically taking place? We need to match the entries in column 1 to column 2. Coefficients of x to the power 7 and x to the power 8 are equal in the expansion of 3 plus x by 2 whole to the power n. Again, if I talk about the general term, it is equal to what? It is NCR 3 to the power n minus r, x by 2 to the power r. Right? I am talking about the 7th and the 8th terms. This is T6 plus 1 and then I want T7 plus 1. T6 plus 1 gives you what? This is NC6 3 to the power n minus 6, x by 2 to the power 6. Right? And this becomes NC7 3 to the power n minus 7, x by 2 to the power 7. Right? 3 to the power n minus r, x by 2 to the power r. Now, if I am saying that coefficients are equal, if the coefficients of x to the power 6 and x to the power 7 are equal, that means x to the power 6 has coefficient what? NC6 3 to the power n minus 6 upon 2 to the power 6, and coefficient of x to the power 7, and this is x to the power 8. If I talk about coefficient of x to the power 7, it is this actually, and coefficient of x to the power 8 will be NC8 3 to the power 8, x to the power 8 upon 2 to the power 8. So this is coefficient of x to the power 7. This is coefficient of x to the power 7. This is equal to coefficient of x to the power 8. And now from here, when you try to talk about what is the value of n, you basically get, this is 7, you basically get NC8 upon NC7. NC8 upon NC7 gives you 3 to the power n minus 7 into 2 to the power 8 upon 2 to the power 7 into 3 to the power n minus 8. So this gives you what? This is 3 to the power n minus 7 minus n plus 8. So this is 3 into 2, right? And this is NC8 upon NC7. From here, you are going to get n equals 55. So the first very A gets matched to R. So corresponding to A, you get R shaded exactly in a similar manner. Coefficients of x square and x cube are equal in the expansion of 3 plus 9x by 7 whole to the power n, exactly in the same fashion. When you follow, what is it that you get? You basically get B getting matched to S. It is for n equals 9 that coefficients of x square and x cube are equal in the expansion of 3 plus 9x by 7 whole to the power n. Then you have NC6 equals n minus 1 C5 plus 1. Now over here, it's pretty simple to understand. This can be written as n minus 1 C5 plus n minus 1 C6 equals n minus 1 C5 plus 1, which implies n minus 1 equals 6 and therefore n equals 7. So C gets matched to Q. And NC2 equals 990 is very simple. Just plug in n equals 45. 45 C2 is 990 and therefore D gets matched to P. Clear? Moving on to the next, we have, this is my N and CR is actually NCR. Statement 1 and statement 2 are given to us. Let's talk about them. Over here, C0 minus C1x plus C2x square minus C3x cube plus and so on. This can be written as 1 minus x whole to the power n. We have done this expansion. Now what you do is you multiply both sides by x to the power k minus 1, okay? And then what you do, you integrate from 0 to 1 both sides. When you do that, you basically get your statement 2. What do you get? You get your statement 2, which is C0 by k minus C1 by k plus 1 plus C2 by k plus 2 minus and so on minus 1 to the power n Cn by k plus n. Okay? And on the right hand side also, you are going